Hello everyone, I am Sivendra Singh. Today I'm going to discuss a question from INMO 2007. This is a problem from Combinatorics computation, which is equal to a sequence of number from A1, A2, an is a computation of the number 1, 2, 3 up to n. Now, this means that if 1 of the computation is like say first it is 3, then 2, then 1, or anything in between. So let the second last be n and the last term be nth term be n minus 1. So this is the computation or the arrangement of this number, this sequence. Okay, now where AI and AZ is said to correspond to an inversion of sigma if I less than j but AI is greater than AZ. Now if you have suppose the number, let's take uh, they have given an example like in this number 24531, there are six inversion. So it is given if I is less than j, then if AI is greater than AZ, then it has one inversion. So the number of times this thing occurs, so the computation has that many inversions. Like here in this matrix, sorry, in this sequence, uh, 2 is 2 is greater than 1, right? But the position at first 2, the position is 1, right? It is at first position, whereas 1 is at the last position, as at the fifth position. So I is this here I is less than j, but AI, that is 2, is greater than AZ, right? In this way, similarly, the other is 4 and 3. So here, this is second, I is less than j, but AI is greater than AZ. And in similar way, this thing is formed. Now we need to find the number of permutations of this sequence 1 to n, where n is greater than equals to 3. Uh, so it is said to prove that there is have exactly such that it has exactly two inversions. So let's begin the solution. Now in a permutation of 1, 2, 3 up to n, two inversions can occur in only one of the following case. Okay, so we are trying to find the ways in which the competition can occur. So note that there should be exactly two inversions. So what are the first possible cases? Can you guess? Let's try here. One of the possible cases is that if the sequence is this way and it has a this term, some term j plus 1 and j plus 2, and similarly it has some other term k plus 1 and k plus 2, it goes up to n. So if this is directed to, if I change this position, okay, from j, if j plus 1 comes here and j comes here, okay, then how many inversions are formed? Then exactly only for j and j plus 1 term, az will be az after the inversion. See here, like 1, 2, 3 up to then here in jth term j plus 1 is has come, after that j, and then j plus 2. So how many inversion is here? See, only up to here. Don't talk about this right now. So here exactly in the jth term j plus 1 is here. So j is less than j plus 1, but aj is greater than aj plus 1. So it has inversion 1, right? And all the other cases are as well in the kth term. So k plus 1, k and k plus 2 up to n. So it has, this has inversion 1, right? And similarly this has inversion 1. So the total inversion is 2, right? So okay. So this is our one possible cases. Similarly, the other case can be is 1, 2, up to some kth term this way up to n, right? If it transform to, or if this permute to, uh, as 1, 2 up to k plus 2 is here in the kth term, and then k, and then after k plus 1 up to n. See here in the kth term, right? K plus 1 and k plus 2, ak ak is greater than ak plus 1 and ak plus 2, right? And all the rest thing is there is no inversion, right? So here is exactly two inversion. It is made by k plus 2 due to k plus 2 before k and k plus 1. So here is two inversion, right? So this is another possible case. And the third possible case is very similar. If this is, sorry, k plus 1, k plus 2 up to n, then if the transformation is 1 to k plus 1, then k plus 2, k up to n, right? So here we can see here is one inversion, right? Because k plus 1 has arrived at ak is here. We can see here is k plus 1, k plus 2, and k. So this is because of this. Here is one inversion because of k plus 1 and k, and here is another inversion, right? K plus 2 and k. So the total is two inversion here as well. So let's start counting the possible number of ways. So number of ways in A. So let's calculate. So let's recall. In A it was j plus 1, g, and j plus 2, right? Similarly, k plus 1, k, and k plus 2. Then in how many ways? Suppose j is equal to 1, okay, without the loss of generality. Okay, so let's begin. If j is equal to 1, k can take values in n minus 3 ways, right? Because it can take values from 4, 5, 6 up to n, right? Similarly, if j is equal to 2. K can take values in n minus 2 ways, right? And similarly, if j is equal to n minus 5, k can take values in exactly one ways. Why? Because see, I'm just writing the last question, 1, 2, up to uh, n minus 5. So see, this is j, this is j plus 1, this is j plus 2, and then after here comes k, here k plus 1, and this is k plus 2 at the top. So this is the last possible cases, and here k can take values in exactly one ways, right? So we calculate the all possible number of ways in which the competition takes of the form a. So that is the sum of all the possible ways, right? So that will be 1 plus 2 up to n minus 3, right? So as you know, this is n minus 3 times n minus 2 by 2, right? Where n is greater than 3. Okay, so this is the first possible case, and in the second possible case, we first recall uh, 1 to here k plus 2, k plus 2 comes first, and then after k and k plus 1. So in how many ways this can happen? So it's very simple to see. If k can take values, if k can take values either 1, 2, up to n minus 2, right? Because at n minus 2th term, the nth term will be k plus 2. So it can take values, number of ways we can take values is n minus 2, in which k can take the values. Similarly, in third ways, it is exactly same. So here again, the number of ways c can occur is n minus 2, right? Um, Hence, so number of ways, total number of ways is, let's write in the first place, uh, total number of total number of ways uh, is equal to, in the first case we have uh, this one, right? N minus 3 times n minus 2 whole divided by 2, correct? So n minus 3 times n minus 2 by 2. That was the first case. And in case B can happen in n minus 2 ways. And similarly, case 3 can happen in n minus 2 ways, right? So uh, simply you can get it as n minus 3 plus 2 plus 2, that is 4. So this is equal to n minus 2 times n plus 1 by 2. Okay, so this is our required solution, n minus 2 times n plus 2 by 2. So this is the number of permutations of uh, this sequence such that it has exactly two inversions. So this is how this problem is solved. Thank you and have a nice day.